Okay, so this is homework session for no homework session. Yeah, homework session for problem set 4. Um, so I'm gonna go through every problem step by step. Um, and if you have any additional question, please email me. Sorry about earlier. Um, yeah, let's get started. So, question 1. Let's do the basic setup. U of x1, x2 equals to q x1 b plus 1 minus q x2 b. Okay, so A, asking about MRS. So MRS is equals to negative mu1 over mu2, which is equals to du dx1 over du dx2. So let's find the first part. Du dx1 is equals to b q x1 to the b, and du dx2 is equals to b to the 1 minus q x2 to b minus 1. Okay, and then we divide them up. We get, so b cross it out, and we get q over 1 minus q, and x1 over x2 to the b minus 1. That's our MRS. And yeah, B. So our budget function looks like m equals to p1 x1 plus p2 x2. When p1 equals 1, p2 equals 2. So assume price are price of a good 1, that's 1. Price of a good equals 1. And income is some value of m. Solve for the demand function of x1 and x2. Okay, so we want demand function. So demand function, it's derived from the utility, and we use that sort of like the ratio of goods 1 and goods 2, the preference ratio of goods 1 and goods 2, and then we plug that in to our budget. All right, so we have our budget m equals to p1 x1 plus p2 x2. So we need to find the ratio. So we already have MRS. We just need to isolate the x1 or x2 in this case. So let's just focus on this. Oh, I missed a part. Okay, so we need to find the slope of the budget line as well. Okay. So how do we like interpret this? Is basically the tangency condition of the budget and the utility. So slope of the utility and the budget must be the same. That's when we have the tangency condition. So we need to find the x1 and x2. So we have MRS, we set them equals to the slope of the budget. Let's find the slope of the budget first. So the slope of the budget, we need to isolate x2 on the other side. So we have P2 x2 is equals to m minus P1 x1. x2 equals to m divided by P2 minus P1 over P2 x1. So the slope of the budget line, it's minus P1 over P2, which equals to minus 1 over 1. Okay, so we know that the MRS and the slope of the budget is both negative. So we can just like cancel out the negative and we set them equals to each other. So we have Q, 1 minus Q. And let's move this thing to the other side. We have x1 over x2, b minus 1 equals to 1 minus q over q. Now we need to get rid of this b minus 1. So how do we do that? We can just divide, well, not really divide, but take the root of b minus 1. So taking the root of b minus 1, it's same thing as divide by, well, the exponent of 1 over b minus 1. Okay. So you do it to the both sides. Cancel out. We got x1, x2 equals to 1 minus q, 1 over b minus 1. And let's isolate x1. Easier. x1 is equals to 1 minus q over q, b minus 1, x2, and x2 is equals to, flip the whole thing, flip the whole thing, divide, multiply. Okay. Yeah, flip the whole thing. So x2 that's it. Okay, so we have the two kind of first order condition that we found. No, first order condition. Some of the ratio of like what x1 equals to and x2 equals to from the marginal rate of substitution. and we just plug it in into our budget. So budget equals to P1 X1. So let's first find demand for X1. So demand for X1, we just need to plug in the X2. Oh, this is long. Okay. Okay. Wow. Okay. So 1 m equals to x1 plus 1 over minus q times x1. So we have 1 plus m x1 demand is equals to m divided by the whole thing. Okay. So that's the demand for x1. Uh, mm, okay, we're good. For goods 1, let's do goods 2. So goods 2 would be, just shrink this a little bit. We don't need that many. Oh, okay. So let's put goods 2. So we substitute goods 1. So we have m equals to p1. X1 got substituted by 1 minus q to the 1 over b minus 1 x2 plus p2 x2. What we have is n1. Yeah, let's just not do that. Uh, so this is 1 minus q over q and b minus 1 multiplied by x2 plus 1 multiplied by x2. So what we have is 1 minus q divided by q plus 1 times x2. So we have x2 on both sides. And we just simplify it. And we get x2 demand equals to m divided by that whole term. That's it. That's the how you find the demand for x1 and x2. Okay. Relatively painless. Mm. Okay. So let's keep going. Question 2. So Tally consume only coffee and juice. Suppose Tally reduce her consumption of coffee when price of the coffee goes down. So Tally's demand will look like price of coffee. So price of coffee goes down. Price of the coffee goes down. Price of the coffee goes down. And then she consumes less. Hmm? Okay. Oh, okay. So it looks like this. So price of the coffee, if price of the coffee is increasing, then Tally consume more. Okay. So this is a classic example of given goods. Okay. Um, so this question has not like really talked about anything related to income. So it's more of like just like income is constant if price of goods goes up and down. Okay. So let's look at A, truth or false. If coffee is an inferior good. Coffee is an inferior good. Yes, it is. Because it's inferior goods, right? So oh, no, it's not inferior. What I'm trying to say is uh that coffee is a given good, and given goods it's a subsection, subsection of inferior goods. Um, so it's like a very particular inferior goods. So it is an inferior goods. Uh, you have to expand probably a little bit more, talk about a little bit into the given goods. Um, but I'll let you to do that. Part B, coffee and juice are gross substitutes. Are they gross substitutes? What's the definition of gross substitutes? So definition of gross substitute is when price of coffee increase, you will consume more juice. But in this case, you consume more coffee, right? So they are not gross substitute, right? Actually, in fact, gross complement. Um, I'll let you guys to figure that one out. Uh, yeah. Okay. Question 3. Did I do this too fast? Oh no. I think question 4 is a pretty hard one. Okay. Question 3. Consume, consider a consumer with a utility function x1 and x2. He initially faces price 1, price 2, income m, but later price good 2 rise to k as shown in class. Okay, so let's just draw really just a graph. Like to sort of like conceptualize the point a little bit. Um, it's a concept. So let me just like draw it bigger. Okay, beautiful. Okay, so this is the initial point, A, and the goods too rise to K2. So our budget change. We can no longer afford that many X2 because it become more pricier. So the first one is P2 over M. Oh no, M over P2, M over P1. This green one is K M over K2, right? Okay. Oh, my drawing. Oh God, they're so ugly. Um, it's horrible. Yeah, that'll work. Okay, so we have a point here. Look at the point. His new bundle is C. So this is bundle C. And the income and substitution effects is B. Okay. Okay. So what we know about substitution effects is holding utility constant, right? So the first scenario is I can afford bundle A. And suddenly price increase for goods two. I no longer can afford bundle A. I can afford bundle C. So if I would have the same utility as before with my current uh, price ratio of goods one and goods two. That's how we find the substitution effects. So we'll just move this green line. Just copy, paste. So parallel and move up and touch the original utility. Right? So that's point B. Okay. So let's take a look. How will the price change of goods two affects our consumption of X1? Okay. So this from point A to point C, this is our total effects. Right? From point A to point B is substitution. So our income effects, substitution effects, it's going this way. And then total effects is going this way as well. So income effects must be from B to C. Right. Substitute, it's going this way. And we have it this way. So substitution effects and income effects, they cancel each other's out. And then we get a small tail of moving up. This is the total effects. Okay. So everything is like, just imagine there's a straight line. If you could. Yeah. Okay. So that's the basic uh like kind of like the foundation intuition from the graph. Okay. So that's what we're looking at the from the perspective of x1, right? So let's take a look at the perspective of x2. What's the income substitution and total effects of like consumption of x2 because the change in price of x2. So our consumption of x2 actually drop. I'll just imagine that this is lines up. Ah, like, can I straight line? Like, is this straight? Yeah. No. Why does that not look straight? Yeah. Well, imagine that's a straight line. What? Yeah. Um. So this is the total effects right here. So from this like x2 of A unit and to x2 of C unit, right? So the total effects actually all goes down, right? So this substitution effects, imagine this straight, yeah. So this part would be sub effect, and this part would be income effect. Okay, so a add up together, you will get a total effects of x2. Well, in terms of x2's angle, not x1, right? Okay, so we have this like really rough graph and intuition of what's substitution effects and what's income effects and how they kind of like mechanically works in the graph. And now let's try to solve question 3. I mean, question 3, you don't necessarily need all the things. I think it's just asking you to write down the setup. So let's do A. So profit maximization and expenditure minimization problem that must be solved for determine A, B, and C. Okay, so for point A, it's pretty easy. It's just a normal max x1 and x2 of utility of x1, x2, and subject to our budget. Where's our budget? Budget. Do we have budget? Oh my god, that sounds crazy. subject to P1 x1 plus P2 x2 minus A. Right? So that's point A. So point C is the same thing. So point C, it's just it has different budget. Not different budget, but it's like different price ratio, right? Because we change from P2 to K2. So in this case, we have max x1, x2, or the utility of x1, x2. See, utility still didn't change, right? It's still the same function that span the whole I don't want to say dimension, but the whole space. And then we tie that utility function into one line where it's tangency to our new budget, right? So subject to P1 x1 plus K2 x2. Okay, so let's do point B. What is point B? So point B is a minimizing problem where we know that the utility it's the same, but the budget change, right? We don't know how much M that we need to have to go back to the same utility before the price increase, right? So we'll have a min of x1, not min of x1. What am I talking about? Let me just double check. Ooh. What did I roll? Okay. Yeah, it is. Min of x1, x2. We don't use the utility anymore. We use the budget. So we have P1 x1 plus K2 x2. And subject to a utility of x1 and x2. It's constant. Right. Yeah. Well, I mean, I don't think I should write it like that. I think I should write it like this. Okay. So we're trying to let me show it animatedly. So we have this. How am I gonna show this? Let me just draw it. It's easier. Okay. So the before the regular maximizing problem, that utility maximizing problem, we're kind of like doing this. we're doing this. We're doing this. Dun. But with minimizing, we're trying to do something like grabbing the budget to touch the utility. Because we're subject to a fixed utility, right? Before we're subject to a fixed budget, right? You have a spam of a utility, and you're trying to touch it. And then now the minimizing problem, it's you're trying to touch a utility at a certain level, at a fixed level, right? Because we know that in point B, it has the same utility or point A. So they must lie within the same utility, right? So that's the substitution effect, right? So that's how you find point B. Okay, let's do B. Hmm. Perfect complement. So this is gonna be super easy. It's just gonna look like this. I just okay. Yeah, it touches. Okay. So the price change from P2 to K2. And X2, X1. This is P divided by P1. Okay. So this whole thing, total effect, it's actually all income effect, right? Because they're a perfect complement. Uh, like you can move this new budget line. Like it's still the same point, right? Right. No matter where you move, it's gonna be the same point. Like you can't like touch here. Like it doesn't really work. Uh, yeah. So there's no SE. Yeah, that's pretty much it. But like when you train your homework, make sure you explain a little bit more. Um, I'm just like going through this a little bit fast. Like I don't think I should write out all the answers. Um, but yeah, that's the intuition for A and B. It's just the graph. Okay, let's go number 4. Oh, so problem set 3. Um, I have the bundles. Let me just like quickly write down the setup and the bundles. The optimum bundles, so we can like speed it through. You can refer back for problem set 3 if you want. Um, so the utility is equals to U of Sj 3 S 1/2 J 1/2. And we have price of 1 equals to um 16.4, right? And we have a change of price of shirt into 16. Okay, let me just grab this monster from question 3 to help us with this problem. I guess I'm too lazy to draw another one. Oh, this is shirt. This is jeans. No, no. Shirts increase the price. Okay. Yeah, I have to draw another one. It's fine. It's fine. It's fine. It's good. Okay. Let me just draw the graph. Okay. So price of the shirt increase by whatever. And then it looks like this. We can no longer afford that many shirts. Come on. Oh, this is terrible. Oh, better. Okay. We ignore this. We can still use this. Okay, something like this. Yeah. Okay. So we have bundle A, bundle C, and bundle B. I don't know if it's exactly look like this. Oh, let me check. Yeah, it does look like this. It's a little bit obscured, but it's okay. Okay. So from previous problem set 3, ps3, we get the first bundle, we get four shirts. So A, bundle A, we get four shirts and 16 jeans. with budget equals one. One what? What am I looking at? Oh, 128. Right. So bundle A is 416, and bundle C we get 4 and 4. So this is the optimal bundle for shirts and jeans. So this person, I think it's Anna, I believe. Yeah. Yeah, Anna. So Anna it's buying 4 shirts. No, 16 shirts and 4 jeans. After the price increase, Anna is buying 4 shirts and 4 jeans. That's from problem set 3. Um, let's look at this problem, like, and try to solve it. For part A, devastated by the sudden price increase, Anna decides to ask her mother for money to help her finance the clothing purchase. What total income will keep Anna exactly as happy as she was before the price change? Right. So in order for us to do that, we need to find out how much the income did increase. M to the M star, right? How much did the income actually increase to get back to the point B, right? Because we couldn't never get back to A because I mean bundle A. It's just simply because the price change, right? Because if we give going back to bundle A, it will look like this, and it will not be there isn't well, it wouldn't be tangency anymore because right with our new price ratio, it wouldn't be tangency anymore. Like if we go back to original bundle, if Anna's mom like give her enough money to buy 4 jeans and 16 shirts, Anna would not buy 4 jeans and 16 shirts. Right? Because the substitution effects will change her decision of buying shirts and jeans. So this is for part A, it's the expenditure minimization problem where we minimize x1, x2 using oh using the new price, which is 16. So we have P S star S plus PJ J and subject to 3S 1/2 J 1/2 minus U constant. right? Because that our utility must be the same. As we can see, like the B must stay in the same line as A. Like this to, like, can I just like do something with it? Like this thing? Like they're in the same utility, right? So what's my utility at point A? So my utility at point A is 3 times, what's S? Oh, S is short. Okay. 16. 1/2. 4, 1/2. So it's 3 times 4 times 2, right? So the so equals 24. So our initial utility is 24. So we need to subject to the initial utility. We get the utility constant would be minus 24. So we will have Lagrange equals to P S star S plus PJ J minus lambda 3S 1/2 J 1/2 minus 24. Oh God. Okay. So this is kind of a scenario where we putting like this M into like the income just like magically just disappear because we were trying to find like how much income, right? We're trying to match like I'm gonna do a tiny animation here. And so like we're trying to find this line, right? Like there's a spam, like there's infinite like combination of, well, not combination, it's just like infinite combination of jeans and shirt that I can afford. Like infinite, like it's a span of space. So like it is and then we're trying to minimize at a point B, right? With a fixed utility. So that's why we don't have like a M here. And we have a constant utility here, okay? DL ES. And then we're just trying to do the whole Lagrange again. And then you will find the optimum bundle point of jeans and shirt. And then you can use that to find your income level. Okay. So let me just do that really quick. So DS, that's 16 minus, oh God. Yeah. Okay. This is not good. This thing is too ugly. Ready for this? Okay, not too bad, not too bad. Not too bad. I thought it's gonna be like terrible. Jeans 16 minus lambda. I mean, I'm sure there's like a faster way of doing this, but I'm just like doing the way that you're supposed to, with cost minimization. Mm, okay, let me just make sure to shrink this video not over an hour. Okay. Um, okay. No, there's no way. This is gonna be over an hour. Um, so gonna be so annoying. 16 equals to yes, equals 1/2 minus 1/2 lambda. So divided by 16. No, 16. It's divided by that. Okay, this thing is on the bottom. Lambda 1. And then this 16 over 1/2 third s 1/2 j to the negative 1/2 plus the lambda 2. Okay. Um, we just divide the lambda up. Let's see if we can make it quick. Nope. No, 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 no. If I do it quick, it will be the best. Oh, am I still recording? Yeah, yeah, yeah. Good, 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 good. Hmm. Uh, okay. So let's find it. Uh, lambda 2 over lambda 1 equals 1 equals to just copy and paste equals to this. Equals this multiply by the flip of that. Hmm. Okay, beautiful. Okay, so we cancel out. Cancel out. So we have a term. It's basically the, oh, 1/2 cancel out too. Oh, let's just cancel out the things that we can. S to the negative 1, J to the 1 equals 1. All right. So that's our condition after you simplify this whole junk. So let me just quickly go through this. I can't jump too much. If I jump too much, it'll be confusing. So -1/2 S and J to the 1/2. So how to treat this exponent? So -1/2 divided by 1/2. So S to the -1/2 itself is already equals to S to the 1/2, right? So if negative to divided by the negative, it's just S equals to -1/2 minus 1/2. So you just combine them, you get S to the -1. And if you have positive on top, so J 1/2, you divide it by negative. So divided by negative, it's divided by negative. So it become positive. So J become +1. So this case, we still have 1 equals to S -1 J1. So S is equals to, oh, I can jump again. So this is equals to J divided by S is equals to 1. So J equals to S. This condition is, this is the ratio. Okay. So we have that. And then this is where it's tricky. So before we plug it into the budget, but now we're plugging into the utility. Okay. So let's plug into the utility. So our utility is, let me just copy and paste. We found the ratio, and then we're trying to plug it into the utility. So 3 S equals to the J. So J 1/2, J 1/2 minus 24 equals 0. 3J 1/2 equals 24. So 3J equals 24. J must equals to 8. Okay, so we know that J equals to S. Therefore, S must be 8. Okay. I hope this didn't confuse anyone. We're trying to find point B, and we got point B. So when we do the minimizing problem, we get bundle B. B of B equals to, well, equals to shirts and jeans equals to 8. So our new bundle must be 8 and 8. So how much will Anna's mom has to give to her? So this from here, it's gonna be pretty trivial. So it's just 8 times 16 plus 8 times 16. That gives you, let me see, 56. So originally she has 128. So 256 minus 128. 128. So part A. Oh, total income. Oh, it's asking total income. It's not asking how much it changed. So the total income would be 256. Okay, not 128. But like Anna's mom has to give Anna 128. Okay, so let's look at B. Oh, this is so messy. Okay, let's look at B. Unfortunately, Anna's mom refused to give her any money. She is now back in the situation described in part C. The price of shirt has increased from 4 to 16, and her income remains unchanged at 128. Decompose the total change in consumption of shirt into substitution effects plus income effects. As defined in class. Draw a clearly labeled diagram with a shirt and horizontal axis. Okay, I think I just did. I did. Okay. So this part, the blue part, will be. So let me just like go deep. So let's do first one. This is the total effects. This sub effect. This. Yeah, it's okay. You get it. Income effect. Okay. Um, that's it. That's it for today. I'm sorry that the video is a little bit long. Hopefully it's helpful. If you need any more explanation on the min expenditure minimization minimization, let me know. I hope this is clear. Um, yeah. Peace out.